Okay, so today we're going to go over a little bit more CER practice, kind of going off of some of the questions we did last time. Okay, so this was the first question we got last time, which was pretty easy, right? Are cats or dogs better? In other words, which one's a better pet? So I'm going to go over some things that I saw, and I'm going to work through examples so you guys can see what a CER looks like and what the format that I want looks like. Okay, so let's say I'm going to go for now with dogs are better. So that's going to be my claim. A lot of you guys, what I saw, you put dogs are better because, and you started putting evidence in your claim. Okay, I just want you to keep this simple. Remember, it's just a simple sentence that answers my question. So all I have to say is dogs are better pets or cats are better pets. So I'm going to go with dogs are better pets. Okay, so I'm going to say dogs are better pets. And of course, this is just opinion based, right? So that's my claim. A simple sentence that answers my question. All right, now I have to pick some evidence. Remember, one piece of evidence isn't enough. I need to pick at least two, and ideally you want to pick evidences that counter each other. That it proves your point, but also disproves the other point. Okay, so I'm going to say, I'm going to talk about dogs, like being protected, right? So dogs, so my first piece of evidence is going to be dogs bark at strangers that come to my house. Okay, so that's my first piece of evidence. That should be bark. Dogs bark at strangers that come to my house. Okay, now let's pick another piece of evidence to kind of go opposite of this. Okay, so what about, so talk about cats. What about cats? Well, cats run away from strangers. Okay, so I said something, I provided some evidence. Now I need to put my reasoning. So a lot of you guys, for your reasoning, you kept putting more evidence that like you didn't connect this. So for example, a lot of you guys put like therefore. So for this example, you put like therefore also dogs are very fuzzy and they play a lot. Yes, that's more evidence. That's not reasoning. Reasoning is going to connect this. Okay, so reasoning, you have to say something like, therefore, dogs are better because they are more protective compared to cats. Okay, or I could say something like, therefore dogs are better because they are more likely to protect you compared to cats, or dogs are better because they keep your house safer, whereas cats don't do anything to keep your house safe. Okay, so you see how I'm mentioning the fact the protectiveness has to do with this, and I'm mentioning that dogs are better pets. Okay, so I'm connecting these two. I can't just put more evidence, and I can't put random evidence that doesn't support this. Okay, so I kept this one simple. Let's go ahead and go through another example. So we're going to go through two more examples. So this next example is a little bit more complicated, but it should look familiar because this was one of your options of the first CERs that we did in class. So let's read it and we'll kind of get into it, okay? So it says, Max has been assigned a science fair experiment and must research a topic related to photosynthesis. After look at the equation for photosynthesis, he notices that light is listed as shown below. So there's this equation, light's listed here. Max chooses to explore the effects of light on plant growth. Okay, he replaces 3 sunflower seedlings in 3 separate pots. He allows them to grow for 2 weeks and measures the growth of each plant. The pot that was placed in the basement with no light reaches 2 centimeters. So it's kind of important. The plant in his kitchen was a few feet away from a window stall that allowed some light in grew to 20 centimeters. So the one that had a little bit of light grew to 20 centimeters. The third pot, which sat directly in the window, meaning that it got a lot of light, grew up to 30. Okay? All right, so here's my question. How does light affect plant growth? So remember, my claim has to answer this. I can't say something, water makes plants grow more. That might be true, but that's not answering my question. My question has to be related to this, and my claim has to be supported by my data. So if I look at my data, basically I'm seeing that when there's more light, they're growing more, right? Okay, so I'm going to say increased light, or we'll just keep it simple. The more light a plant gets, the more, or the taller, I'm going to put the taller it will grow. Okay? So that's my claim. The more light a plant gets, the taller it will grow. I keep it very simple. It's answering. How does light affect it? That's how it affects it. More light equals a taller plant. Okay? Now let's pick two pieces of evidence from here. So I can say, so for the evidence, don't put your opinion, just put simple like facts. So I'm going to put the first example. The plant in the basement, right? The plant with no light grew 2 centimeters. So that's kind of disproving, that's showing that we need light, right? If I were to just leave this like this, that wouldn't be sufficient because I need to also prove that. I'm disproving, I'm showing that we need light, but I'm not showing that light causes growth. So I have to always pick like two examples to really prove my point. Okay, so I'm going to pick the last example, that the plant which had a lot of light grew to 30 centimeters. Okay, so that's proving my point, right? And this is also proving my point because the one that didn't have light only grew 2 centimeters. Okay, all right. Reasoning. Okay, so therefore, I'm going to have to kind of connect it. Therefore, the more light, or you can put something like therefore, according to the data above, the more light that a plant receives, the more that it will grow. Okay, so I'm not going to finish this. I just want you kind of to think about what it would be. Okay, so therefore, according to the data above, the more light a plant receives, the more it would grow. Okay, again, connecting this and this. Or I can say like, therefore, we can see above that when the plant received more light, it grew taller than the plant that didn't receive any light. So kind of we're touching on both examples and proving our point. Okay, so again, this is like a summary and an explanation of these two, connecting those two together. All right, so what we're really actually eventually trying to get at though is do physics CERs, which we haven't done yet, right? So I'm going to pull up the last graph. This is the more important problem because this is what you're actually going to be, these are the type of problems you're going to be doing. So this graph should look familiar. We did this in the Nearpod last week. Okay, so it says the graph above shows a snowboarder's trip. I kind of switched the question here. Keep that in mind. For safety reasons, the forest ranger recommends traveling no faster than 15 meters per second. Okay, those not following the rules will be banned from the park. All right. So we're trying to figure out this question here. Should the snowboarders be banned from the park? All right. Well, to figure that out, when you have questions like this, you actually first have to solve the math work behind it. You can't just go straight to the claim because we don't actually know yet, right? So we know that this is we know that this is the speed that's recommended, and if they're going over that, then yeah, they should be banned. But if they're not going over that, then we shouldn't ban them. Okay, so let's figure that out. We know that in these type of graphs, which are distance time graphs, if I get the slope, I can get the speed. So let's do that for each part. Well, for AB, I went up 200, and I went to the right 10. So my rise was 200 divided by 10. So we'll do that math around, okay? For B to C, there was no slope, so my speed was 0 meters per second. So I don't even need to do that one, right? And from C to D, I went up, I started at 200 and I went up to 500. So that means I went up 300. That was my rise. And I started at 30 and ended at 60. Started at 30, ended at 60. That's 30. Okay. So if we do the math here, 200 divided by 10 gives me 20 meters per second. This gives me 10 meters per second. Okay. So in other words, those were the three speeds. All right. So for my claim, I need an answer. Should he be banned? Well, if I look at this, actually he was being unsafe here. He was going over the speed limit here, right? So I'm going to answer this question. Yes, he should be banned. So yes, he should be banned from the park. Okay? From the park. Okay? That answers my question. Now, for my evidence, you can just put this math work if you want. So if you can take this math work and just put it in, or you can describe it. So I can say something like, also right here, there's no explanation. It's just simply data. So in segment A through B, he went 20 meters per second, right? I can show the work. In BC, he went 0 meters per second. So that would be my second piece of evidence. And then my third evidence would be, and in segment CD, he went 10 meters per second. Okay? All right, so I provided evidence, I said something, now I got to explain it. All right? Well, I said he should be banned, but why should he be banned? Well, I provided evidence, so now let's connect this evidence to why he should be banned. So, therefore, since he went 20 meters per second, which is over the park's speed, he should be banned. Okay. So again, that's what we're trying to figure out. So, okay, so we're trying to in this part here, we're just connecting this to that. Okay, so therefore, since he went 20 meters per second, which is over the park speed, he should be banned. So all I did is I connected this to that. Okay, so these are the type of problems you're actually going to be looking at.